All right. Welcome to my show. My name is Bret, and I'm live like this every Thursday. You can come and hang out with other DevOps professionals or people that are interested in getting into DevOps. And I talk about containers a lot. So that's why the word Docker is in the title. And today I'm going to go through a bunch of stuff I've been working on lately. This year, I've been all about GitHub Actions as it has matured over the last few years since it was released. And there's just enough features to start making it worth, I think, an actual enterprise or team of people to actually get into it. We can always talk about limits and certain roadblocks that I've run into, and I'm warning you that I don't know everything about GitHub Actions. So there's probably some things that I'm just learning. In fact, I learned some stuff today from another Docker captain, Kevin Alvarez, who is Crazy Max, which we'll talk about him in a minute. But anyway, the the world of CI is vast and complex, and it's super hard to figure out what the choices should be. And the reality is most of us, kind of like our networking infrastructure, when you show up at a company, they usually already have a CI chosen, right? They've picked the winner for that period of time. And more often than not, then that's probably Jenkins. And then what's often happening is I see companies trying to shift off of Jenkins, but they don't get everything off of Jenkins. So they still have Jenkins, but now they have this other thing too. And it just even gets worse. So what I think, and I will say that I'm bullish about GitHub Actions, is when most of us are keeping our code in GitHub, granted, not all of us, but even if you have your code somewhere else, you still have to use GitHub every day because you're using open source, and most of the open source is on GitHub. So you can't avoid GitHub as a browser tab. And that means that you're not just doing CI on your own stuff, but you're probably a little bit concerned or interested in the CI of the things you're using. And that's been a real big challenge over the years is if you're using open source, how are they testing it? You know, what are their tests failing? And so we all see these little badges, right, that show up in the README. And oftentimes what I'll find is certain projects, I'll click the button and it'll take me to a completely different website for a different CI system. I may not know that CI, so I'm fumbling around trying to find what is it they're testing and what's failing and what's not. And then a lot of times I just want to have access. Like it's one of those things where the source code is open, but the access to the CI isn't. So that's less common nowadays, but has been a ongoing problem for over a decade for me, ever since GitHub was launched and we all started seeing things like Travis CI. Anyway, that's a big soapbox, but the point of all this is I think now that GitHub is continuing to invest more and more into Actions, and we're seeing Microsoft pushing more of their stuff into Actions instead of other products that they might have, or we hear about rumors of the future of other things from Azure becoming things in GitHub. I think that GitHub Actions is going to be the one to beat, and it's going to be the default. So if we put our source code up, just like, you know, we're using Git by default in GitHub, and then we're probably using GitHub Actions or GitHub issues rather by default. Maybe the READMEs by default. Like there's some things that you might do by default, and then only in more advanced teams do you shift to some other tool for that thing, right? I think that GitHub Actions will be the same way. And you've heard me all year talking about GitHub Actions. I've mentioned them several times, but I don't think I've ever gone through from a repo that exists that doesn't have any CI, and what do we do for setting up a minimal CI workflow that simply is just building images, maybe doing some linting, pushing them to to Docker Hub, or possibly to GitHub Container Registry, GHCR, or both. And obviously you'll want to do some CI actual testing in there. I won't cover the testing part because that's pretty language specific, but I can talk about where that goes and what you can do with that. But I wanted to start from scratch and let's build it. Let's build it live in a repo that I have yet to put GitHub Actions in. So all year long, I've been taking all my open source from the courses, which is dozens of repos, dozens of images at least, probably a dozen repos, and turning those from Docker Hub auto builds, which are really basic. And now we've just got an announcement that they're limited and the free plan won't have any of them for automatic building. And that moving that to GitHub Actions and sort of replacing my Docker Hub auto builds with GitHub Action auto builds. That's basically what I've been doing for 6 months. Not the only thing, but I've been doing a lot of it. So I want to take you through that. And we're going to use one of my demo apps that I have yet to convert. And let's jump in. All right. Before we get started, let me make sure there's not any questions. Hello, everyone, by the way. There's a survey. I don't know if it pops up in your chat, but I'm going to be running the survey all hour and just kind of getting an idea of what people are using. Sadly, the YouTube chat poll only allows 4 options. So it's not that I didn't think of other ones. I just could only list 4. So I listed GitHub Actions because I'm curious how many people are using those today. And then the 2 most populars based on various surveys on the internet are Jenkins and TeamCity, by far Jenkins. but TeamCity seems to be a close second from JetBrains. And then other, which is probably going to be the majority of everyone because we've got, I could probably rattle off a dozen off the top of my head outside of GitHub Actions. And all of these, to me, are fairly the same. To me, there's almost like there's Jenkins and there's the old Jenkins and there's the newer Jenkins pipelines that most people are trying to use, but not always. And then there's all these other platforms. Most of them use YAML to describe the steps. And one of my biggest reasons for using GitHub Actions when you can is that you're meeting the developer where they are. And I'm super passionate about engaging with people with the other tooling that they previously didn't have access to or didn't know where to find it or didn't remember the website address, putting that right inside where they're at, where their code's at. So, GitHub isn't wrong for making all these other apps connect to GitHub. And previously we had Travis, we had all these other tools that would show up in PRs. Now GitHub Actions now will show up in PRs. But if I think of my list of Docker Hub reasons for kind of wanting to get off of Docker Hub auto builds, even though they're super convenient, there's a little list that I have. They're no longer free if you have a free account. Granted, you could argue that they probably could have made them not free at all back in the day, but with so many platforms, like Travis had free builds. I mean, when GitHub's Actions, there are obviously free plans for the free people on GitHub for GitHub Actions. And then there's other CIs that have limited plans or free plans and stuff. So I understand why Docker wanted to do free stuff. If you haven't heard yet, if you go over to the blog at, blog. Over at the blog, changes to Docker Hub auto build. So this was some sad news a couple weeks ago that essentially I put on Twitter. This is why we can't have nice things on the internet. So crypto miners have for years been using any platform that will essentially give them some level of compute. And all it has to be is something that will run a script. So it could be a CI platform. It could be something that provides free instances or DigitalOcean, stuff like that, free accounts up there, free automated things, whether it's, just workflow or scripting tools, any of that stuff is subject to being attacked by crypto miners that will try to bot things and get free compute resources, because who doesn't love free Bitcoin, right? So that's been happening for years, and Docker has now, they basically have said we have to turn off auto builds for free plans because it's either that or we have multiple employees spending all their time trying to stop crypto mining from burning up all of our instances and causing us millions of dollars. That's sad for all of you with free accounts. Now, granted, you can pay $5 a month and get all the auto builds you want. So it's not a terrible expense. However, that's not the only reason I've been jumping ship. One of them is it's not super clear to my students, and I use a lot of GitHub for teaching and showing others, so it's not super clear what Docker is doing in the background with the builds of things, and that's not immediately available on GitHub. I don't even believe there's a badge that Docker provides for builds. It doesn't really show in my PRs at all what's building on Docker auto builds and Docker Hub. There's out of the box, there's no multi-platform support, even though you can kind of hack it together. It's not obvious how to enable BuildKit. What else? It doesn't do linting or testing out of the box. You can technically do that with Docker Compose file, but it's not obvious. It's not first-class citizens. You have to kind of find it in the docs and docs. Anyway, there's just a series of issues of things you would love to do probably in Docker Hub auto builds and to turn it into a lightweight CI solution. But a lot of it's very hacky, and it's definitely not infrastructure as code based, because it's a lot of the settings you have to do in the web interface and you can't do them in code. Anyway, so I know that Docker Hub has plans for all this in the future. They want to do all this stuff, but it's not here yet. And I love teaching this stuff, and I think GitHub's Actions is worthy of a few days of education. So let's do it. This is the repo I'm going to be using. I'm going to put this, just so you have it as reference, into chat. So this is technically a mono repo. I will show you some repos later as we get into this that will be the end result example repos that you can use as templates, which they were just created today, so I don't actually have it all there, but this is me walking you through it. Paul is saying, actually, let's scroll up a little bit. What about Bamboo? There's lots of CIs out there. I have not used them all. So my experience is when it comes to the SaaS market of CI tools, there's not a huge amount of differentiators as much as they all want to tell me they are. You're basically making YAML. You're going to a website, looking at workflows. I think one of the differentiating factors is, does it do continuous deployment well? A lot of them say they do. GitHub Actions is not there yet. It's not great for deployment. For example, they just now have this thing called environments, but it's pretty limited, and it's one of those things where it's an all or nothing permissions model in there. So if I've got a large mono repo, there's no way for me to divvy things out. So it's maybe good for the simplest of workflows for deploying things into potentially dev, test, and prod, but I still think they've got a lot of way to go. So I would not, in my case, what I would probably recommend is do all your testing and Docker image building and pushing in GitHub Actions by default, and then probably use some GitOps workflow where I'm using Flux or Argo, maybe some Helm charts or Kustomize, stuff like that in different repos to automate my deployments. I probably wouldn't lean on GitHub Actions as a way to deploy. But I haven't tried all the different use cases. I just know that out of the box, there's some stuff there that's pretty limited. Let's see, Biker has a question. GitHub Actions or GitLab? I'm doing my own with Bash scripts, but want to move to a more formal, supportable model, but don't need a lot of complexity. I'd love to hear the opinions on that in chat. I only have very limited experience with GitLab CI, and my opinion is if I have to do more than one-line Bash scripts or just one-line Bash lines inside of my CI and CD, then there's probably a better tool out there. And I continue to see this over and over again where teams are limited by their CI. They end up resorting to Bash scripts to hide the complexity or to automate things that they didn't have a tool to do. And one of the strengths, I think, of GitHub Actions is the marketplace, where just like Jenkins, what's one of the other ones? Circle CI, Jenkins Circle CI both have marketplaces for all of the add-ons because that's what you need, right? For example, if you want to simply lint or test something with, maybe you want to security scan something, and you have to then write Bash scripts around CLI tools to do that, I feel like you're already down a rabbit hole that you will end in basically creating a Bash CI solution. And I'm very much against that, except for rare, obscure use cases. A lot of these things everyone's doing. So why are we having to bash it, right? There's better tools out there. And so when you look at the GitHub Marketplace, you start to realize every vendor is throwing their stuff into GitHub Marketplace. It might mean that for paid features, you have to go back to their tool, such as the case of like sneak image scanning. If you want more advanced stuff, you can get stuff from their tool by going to their website, but it'll show up in GitHub Actions. It'll show up in PRs. And I think that's really what we're looking at for the future here. When I start to see a lot of Bash automation, I just feel like that's the old way. That's the Jenkins way from 2010, 2005. I'm looking to get away from that, right? But in terms of GitHub Actions versus GitLab, I would say that GitLab, I'm just going to guess, GitLab has been around longer, so maybe more built-in features, but I bet you the GitHub Actions marketplace makes it richer in terms of plugins. That's just a guess. I could be wrong. Paula says, our company is concerned with running potential high costs. We know how much a Jenkins box and agent will cost. Well, so the thing is if you're paying for GitHub already, you're already getting GitHub Actions that you're not using, right? So here's one of the arguments, and this is why bundling all these things together is eventually going to be the future of the internet anyway. Like we need to put code in. There's a certain set of things we already need with collaborative coding, and GitHub and other competitors like GitLab are continually adding that stuff to it. It's only a amount of time for when those tool sets have the percentage of tools that we all need, except for the rare use cases, right? For example, GitHub Issues is good enough for small teams and open source. A lot of teams jump to Jira when they need to involve more and more teams that are not developer focused, and so then they don't use GitHub Issues. That's a great example, I guess, of how some teams will use Jira, but the default tends to work for a lot of people in smaller teams, less complex workflows. I'm actually, by the way, surprised that GitHub Issues doesn't have as many more features as it does have. The thing about GitHub Issues now is, though, GitHub Actions is making issues better through automation and bots. So that'll be a separate episode. We should do that, and I'll bring on someone who's smarter at that. Hey, Crazy Max. Glad you could join us today. Hello. All right. I'm going to get into this here in a second. I swear I'm not going to use the first 30 minutes to talk about it and not do anything. I think I just specified, GitHub Actions is great for CI, great for building, testing, but I probably wouldn't use it for CD yet. But then again, my CD is probably going to use Flux or Argo or something like that with GitOps and Kubernetes. If I'm going to use Terraform, I might use Terraform Cloud in a larger team. And Terraform Cloud, I would plug into GitHub Actions. And if you go to GitHub Universe from last year, there was a whole keynote, just search like Terraform Cloud, GitHub Actions or something like that. And one of the people from HashiCorp actually talk about how to use Terraform Cloud and all that stuff. So, GitHub Action plus Argo CD. I agree. Okay, so let's jump in. Already behind schedule. Okay, so I've got my app. It doesn't even have a .github directory. Now, you may have known .github directories before because we would use them for issue templates or some of the other things that you might do in your repo, maybe Dependabot or something in there. So I'm just going to click on the Actions tab. It's already there for most of us. I believe that it's available for everyone now. It used to be we had to opt in, but it's just going to be there. I could click one of these and it would automatically create the first action in my first workflow, but I'm just going to say set up a workflow myself. All right. That's going to give me at least the YAML template to get started. Now you'll notice that it's already putting it in GitHub workflows and it's just calling it main YAML. So this is sort of the file path explanation here, is that everything has to be in .github. There are other things beyond actions that go here. And then under workflows, that's where all your actions will live. And then in each workflow, there are jobs, and in each job, there's going to be steps, and the steps essentially are the action. I don't know. The terminology is a little wonky there, but you can name this whatever you want. Each one of these will be its own workflow, and they will show up here as their own thing. You'll see that happen in a minute. And then this is just my outline that they've given me. So the first part is you name it, and that'll be the pretty name that you see inside the UI. Here is basically, this would be if you were using an outside CI, this is where you would set up your triggers for your webhooks. Essentially, what things happen in GitHub that will kick off this workflow. And this one is a nice one that I don't often put in, but I should be, where you can manually kick off the workflow. If you don't put this in there, you can technically rerun old workflows, but you can't just kick off a workflow at any moment. So you throw that in there, and then you can. And so back in original days with GitHub Actions, you couldn't just start a workflow. You had to basically commit and then push, and then it would kick it off, and that was a little limiting. All right, so I'm going to take all of this, and I'm just going to copy it out, because I'm not going to edit this in the browser. It's a little small. It's hard to see. And I'm going to just come over here to my editor. I'm going to create a new branch. By the way, if you're wondering what all this is actually the extension called GitLens. So GitLens adds a bunch of features for Git stuff. So I have that extension enabled. I'm going over here, and under branch, I'm going to create a new branch. I'm just going to call it GitHub Actions init. Yeah. And then inside here, in my branch, I'm going to create a new GitHub. I know this is kind of cheesy to do it in the GUI, but whatever. New folder, workflows. And then in here, I'm going to create a file. Now, this app is a mono repo. So for a regular repo where you only have one Docker file, one app, then you would probably have one workflow to build and test the image and then push it to your registry. You might have a separate workflow for linting, which if we have time, we'll get to. But in my case, I have 3 images here with 3 Docker files and 3 subdirectories. So I'm going to create a separate workflow for each so they can each be built independently. None of these 3 images are based on the same stuff. They're all 3 separate apps, 3 separate Docker file, and 3 separate images that will get pushed. So I'm going to make one here, and I'm going to, if you see, I have DB, Web, and Words. Those are the 3 apps that are all in this one repo. That's what makes it a mono repo, where I have, technically it's multiple code bases as subdirectories. So here I'm going to do the web one first. All right. So web.yaml, I'm going to paste that stuff in there, and then we're going to start from there. Now you can call it YAML. I think actually my standard, now that I think about it, is I always tend to take the A out, even though it's probably cooler to leave it in. So I'm just going to leave it like that. And up at the top, I'm going to copy and paste some of this stuff in for time so that you don't see me typing a lot. Yeah, and Biker, the nice thing is about private repos. So if you do private repos in GitHub, you can use private GitHub runners. I have wanted to do my own runners, which would probably be a little bit faster than GitHub's, although they're fast enough. And I want to do builds natively on ARM instead of using QEMU, which we'll get to in a minute. But GitHub really warns that for any open source repos that you don't use private runners, because if anyone submits a PR, which I do accept PRs from other people, then technically they could be running any code they want inside of your runners. So I don't want that. So I'm scared of that, and I don't think I'm smart enough to try to eliminate all the potential abuse cases there. So I just sadly have to use the public ones, which are fine. All right. So here, what this is saying is a push or pull on the main branch, which is my default branch. But because I'm in a mono repo, I'm going to have to do more than this, because what I want to do, and this is one of my first features that will immediately exclude certain CIs that don't provide this, is I want to do path-based filtering on my actions triggering. I only want the action for this web, this right here, I only want that to kick off if something in the web directory changes. I won't automatically build a new image if anything down here changes, because none of this stuff affects this image or the software in it. When you're building mono repos, which there are opinions about, but if you know what you're doing and you're going to build a mono repo, it's very important that you keep things isolated in their own directories. The worst kind of mono repo is one where this particular set of application code depends on things in this directory and something over there in the root. And you basically end up having to build the entire repo for every single sub application. And that gets really problematic. It ends up adding a lot of things you don't need to your repo. And then you end up building a lot of images that really didn't even change for that particular app because it was maybe somewhere else in the repo. Like, who cares? I don't want to rebuild images when the README changes, right? That could be a lot of time. So I'm automatically going to exclude that by adding here essentially a filter, and it's going to be a path filter. So let's do this here. I'm just going to type this. So under branches I'm going to keep push and pull requests because I think that's appropriate for most people, is on a push to the main branch and then on a pull request to the main branch. That's like the simplest workflow, right? And then there's some things that I want to run in a pull request like testing, but I don't want to push images to the registry unless it's accepted as a PR. So I want to test the images, but not necessarily push them. You'll see that later. So branches main, actually that's going to be a list. And then underneath here, I'm going to have to do paths. Now you can also do paths, I think it's ignore, to do the opposite of this, but I'm going to do paths. And I'm going to specify that anything in web or any subdirectories of web, I think that's the right format, the globbing stuff. You can look up all this in the documentation. GitHub Actions has great documentation and some examples. And of course, there's tons of people doing it. So, and we're basically going to do the same thing up here. So technically what I want is I want two things. I want GitHub workflows web.yaml as well. And this ensures that if my actual workflow for this changes, that it retests and rebuilds the image because maybe I'm adding a new testing feature or something like that. All right. So that, if you looked around my repos, this is pretty standard. I'm only doing it for the main branch, and I'm only in a mono repo. I'm only including the directory. Actually, that shouldn't be web. That should be like that. Yeah, no dot. And then the .github./workflows there. Yeah. All right, so I'm going to do the same thing for pull request. Sadly, there's no way to condense this and say, you can technically put in an array with push and pull request in it, but if they need any other options underneath them, you have to sort of be like this. You have to do it like this, unfortunately. And then we'll keep the workflow dispatch. What you'll see in a lot of other ones as well is I have images rebuilt on a schedule every month for reducing the decaying over time of patches and security stuff. Now, this is probably not something you would want to do with production quality code, but because I'm doing largely this as a teaching exercise, my images might go an entire year without me posting any new examples. But the image that you pull down, I don't want it to be a year's worth of security holes in it. And when you go to Docker Hub and you look at all the sneak security problems, there's dozens and dozens, if not hundreds, of vulnerabilities. So what I'm asking this to do is to rebuild often. And so you can technically do a cron here, and it will rerun this particular workflow on a schedule. Alexander says you could try YAML anchor. I am not sure whether GitHub Actions supports that, but if you can show me an example, great. I have not looked up anchors yet. Actually, with Crazy Max, who's in the chat, we were just having a conversation before the show about templates, which we're not yet quite there with templates. They're calling them, I can't remember what the composite actions, which is not quite ready for use yet. They've got something that's a little more limited, I think, called composite runs. So anyway, we might be back here 2 months with an actual templating interface, but we don't have it yet. But yeah, you might be able to use templates. You might be able to use YAML anchors, which kind of like a template. All right, runs on Ubuntu latest. This is a Linux. They default to Ubuntu runners. I'm perfectly fine with Ubuntu. It puts all the tools there, so we're going to leave that alone. Now, this is the name that you want to have here. If you're going to end up in a mono repo and you want a bunch of the same jobs happening here, like maybe you're pushing a bunch of different images or something, you might have, this is a unique thing, so it defaults to the build name, but you'll probably want to customize this over time. Often what I'll do is I'll just say something like build and push images, something like that. Now, let's get into the meat of it. So you're going to have the checkout. That's standard there. Something in the Docker documentation is suggested that you don't need this, but I have found in a lot of cases that I will eventually need it back in there for other stuff, so I end up just having it. Now, we're going to delete all of this because this is where their example ends. So each one of these is a step in this workflow that we're going to go through. Now, I have a bunch of requirements. One is I want to have... I basically want to push to multiple registries. I want to push to GitHub registry and Docker Hub. I want to build a multi-platform image. So I want it to be for ARM64, ARM v7, which is for Raspberry Pis, and then for Intel, for AMD 64. So I'm going to have to use BuildKit, and then I'm also going to need to use QEMU because currently there are runners available for Mac OS, Windows, and Linux, but there aren't different platforms for Actions yet. So I have to use the QEMU emulator, which Docker does provide. And we're going to set out all that as steps. Now, each one of these things has to sort of be initialized. We first have to set up BuildKit, then we have to set up QEMU for the emulation for different platforms. Then we're going to need to create our tags and our labels and stuff that we're going to use. And then we're going to build and push all as one step inside of BuildKit. And I'm going to use some notes here. So the first one is we're going to set up QEMU. Now, one of the cool things here is if we go back to our, over here, these are the three images I need to create. So each one of these is going to be its own workflow since they're completely separate. If they were based upon one another, or they were very similar, and I wanted to build them all in a single workflow, I could do that in this single YAML file, but I'm going to have them completely separate. So I will end up with 3 files that are extremely similar that probably only have a few lines that are different. That's one of the limitations right now that I'm finding with GitHub Actions, without having the good templating that we're hopefully will get pretty soon. Docker has in the marketplace several official actions, largely supported by Crazy Max in the chat. So everybody thanks Crazy Max over there, another Docker captain, hooking it up and creating some great open source here. So we've got, this one is the build and push. This is the meat, and there's tons of docs here. I learned everything in here about caching, for caching the build so that they build faster each time. Using registries, how to sign into registries, how to store the secrets for registries, paths, dealing with the path and the context of where you're doing it, doing multi-stage builds and how to point to a specific targeted stage, how to do multi-platform builds. There's just a ton in here. So read this, memorize it, because I spent quite a lot of time having to work in and out of this to get what I wanted. The other one that is just a brand new one that Crazy Max was building himself, but now it's an official made by Docker. You can see over here, created by Docker, is the metadata action. The benefit of this is that it will help create some standard labels, which are nice and ideal, and it creates them out of the box, so you don't even have to do hardly anything other than just add this action. And then what else? Oh, and it creates my tags for my images, which in this case, we're just going to use latest, simplest example, but it's very flexible, and you can use all sorts of things like automatic simver, just crazy amounts of flexibility here for tagging your images with specific rules. All right. So you're going to have to read that stuff. Just search in the GitHub's Action Marketplace for Docker. You'll find some of that stuff. Or you can go to Docker, github.com/Docker, and you can find their actions in their repo list. All right. And that stuff is rapidly changing. So it's one of those things where you're probably going to have to check back every couple of months to make sure that you're using the latest design. And I will also put in a link for the documentation that Crazy Max pointed me to. So there's docs here. In fact, maybe I'll back up a second to the, over here, there's docs in the build push stuff. So right now there's just these advanced things. And then inside there's a bunch of examples that I haven't actually gone through yet because I've been doing it all the hard way. All right, so we've checked out our code. Yay. Now I'm going to do 2 different steps here, just for the sake of time. The first one is, oops. I'm going to give it a name. I like names. And then we're going to do this name, checkout, like that. I like to keep the YAML formatting consistent. So I'm setting up QEMU and BuildDex, doesn't matter which order, I don't believe that matters. And then I'm going to set up caching. Now, the caching is a little complex and there are some bugs. So go check out the documentation. I didn't even know about these bugs till earlier today. So if inside of this documentation in the advanced examples, you can read about caching. And in fact, for now, I'm going to leave the caching out. Yeah, I'm not going to leave it out. I'm going to put in my attempt at using the caching. I may have got it wrong, but what you can see here is we have this stuff right here that's going to be added in. And that's going to help us with the caching. And then you see right here where we actually we create an action/cache action. So that's GitHub's thing for initializing the cache, putting it in a specific directory. And then there's this little workaround thing. So I just learned about all this stuff. I've been using caching, thinking it was working. I may have been creating problems all along. I'm going to go ahead and throw it in because you are going to have to at least initialize the cache. And just if you're watching this video later, those are my notes. If you're watching this later, just realize that this may need to be updated to be more correct. Or to at least work with Docker images. All right. And this is, if you're on your local machine, you may not have realized, but Docker build or Docker BuildX build, whichever one you're using, in the background, it's caching the layers in your build so that each time you build, it doesn't have to rebuild every single layer. We also want that in CI, ideally. So regardless of what CI solution you're using, caching is definitely a thing. You should always be setting it up. Docker would have its own cache. Other things that if you did them outside of Docker, like npm installs, any other tools that download and do things on a repetitive basis, they all tend to have their own cache when you're locally on your machine. But if you're in a CI, you would have to usually manually set up those caches for each one of those tools separately. So I'm doing that here. Now, the next thing I'm doing is I'm going to go ahead and log into the registries to just get it out of the way. All right. First, I'm going to add Docker Hub, which is my favorite registry, which is what most people will be using, especially in my courses when they're getting started. So what I have here is I'm logging in. I'm using the Docker login action, which is a separate action that Docker creates. And I'm saying, don't bother doing this on a pull request. This is another tip I actually got from Docker and Crazy Max. So you can use little ifs and withs and things like that. You'll see that inside these actions. The nice thing about an if is I can basically exclude this with a certain type of event. So up at the top, you'll see that this whole thing's kind of running for pushes and pull requests. But what I really want to happen is, essentially, my goal is, if you create a branch, I do nothing. None of these run. If you create a pull request to the main branch, my default, then I want to run the testing. And in this case, my testing is, does the image build? That's my test. And then, and only then, when the PR is accepted into the main branch, that would be the push. Then that's when I want to log into registries and actually push my image up to my registries. So I don't want PRs, in my case, now you might be different, but I don't want my PRs to make new images. I only want them to make new images when they're accepted and merged into my main branch. So I'm putting this if in here to basically say, don't bother logging in if it's just a pull request, because I'm not going to push anyway. And then I like lately, because some people have their own reasons for not wanting to use Docker Hub, maybe because of pull limits, or they just don't have an account there. They're already on GitHub. I like the idea of also pushing these to the GitHub container registry And they actually will then show up in my repo. So you can go to my repo and see the images that I've published, kind of like new versions of a binary or other source code. So I'm going to put that in here as well. And I'm essentially logging into 2 different registries. Now, these are secrets that I have to go get and put into my GitHub registry. They don't exist yet. So we're going to have to do that in a minute. But these down here are kind of nice because this is built in. This is a bonus of using GitHub for your CI, is I don't have to go in GitHub token and then link my CI to my GitHub. This, as long as it's in the same repo that I'm building the source code from, and then I'm going to be pushing the images to, it's just going to use this automatic token. So I have to do nothing other than just put this environment variable in. It just works. All right. So now I've set up Docker, QEMU, BuildKit. I've logged in to my registries. You'll notice that it has the same if here. And I've set up the cache so that our future builds will be faster. Now we're going to do the Docker metadata. And this is an optional step. You don't have to use this step. But what this will do is it will automatically create some labels. And it will put them inside your Docker image, not your manifest, but in your metadata of your Docker images. And you can hard code that, add extras if you want. I'm just going to leave the default. What I am doing here is I'm hard coding the image tags. And in this case, I want this to be the web. And actually, if I go over to my GitHub, my Docker Hub, what are the images that I currently have there? So these are ones that are there today because Docker Hub Autobuilds are building them, and I'm shifting it over. So if I go over to this one, this image is technically still being auto-built. But what I'm going to do is under the auto builds, I am going to turn this off. So it's still connected to GitHub, but it's not going to auto-build anything anymore. I'm going to let GitHub do that for me. And if I look, I just have the latest tag. One of my problems is I want to support ARM V8 and V7. This is a 64-bit ARM and then the V7 ARM. But there's no easy way to do that without some, I'll say, hackery inside of Docker Hub. They don't have their own, as far as I know, QEMU isn't set up by default, so you have to kind of do some workarounds to get it set up, and they don't have ARM builders yet. Same with GitHub. I think that that's all going to work itself out in the next year or two, because every person on Apple is going to have an ARM device, and they're all going to need to have builds for ARM, ideally. So I got a feeling that we're going to have a new rush of ARM-based builders or runners or whatever you call it, workers. All right. All right, so here, all right, I already forgot that name. It was Wordsmith Web. All right. Now, the way that I get it to push to both of these is I give it the tags for each repo. All right. Because when you tag something in a Docker image, that's giving it the location of where it needs to go. So I'm going to tag the images. I'm hard coding these as the latest. You can see that down below. This is kind of a brute force method. You will probably want your own methods with Simver. Like I said, if you just go look at the documentation, it gets really fancy, and there's all sorts of automated ways for incrementing or, doing git commits or whatever you want for your image tags. But I'm just going to hard code everything as latest, and I'm just going to overwrite that image. That is not a production way to do it. But for my students, they only pull the latest image anyway. And I want that image to automatically update with security patches, which is what I'm doing up here at the very top with the schedule, right? We're having the schedule rerun it. All right. Now that we have our metadata and our tags for our images, we're going to do the biggest step in here, which I've added a little bit of a comment. And this is the build and push. So this is the bulk of the work that's happening, and we're going to walk through this step by step. So you'll notice that some of these, by the way, have an ID. The ID is only necessary when you need to reference that step from other steps. So you can have the output of certain steps be the input of other steps and all that stuff. So you need to reference them by ID, and you don't have to have that if you don't ever reference them. So you'll notice that some of mine are inconsistent. They don't have IDs and some of them do. Right? Like this one up here doesn't have an ID because I don't need to reference it. And this one down here does. All right. Let's go through this step by step. So we have the action. By the way, I'm not using a specific version here, which I should be. We'll talk about this with Dependabot if we get a minute in the end to talk about how you can use Dependabot to automatically, if you don't know what Dependabot is, that's a robot that GitHub now offers built into GitHub that will do things for you. And one of the things it will do, besides security updates, is in here, it will automatically send me a PR when my actions versions are out of date. Now, each one of these actions, you may not realize, each one of these steps is an image. So this is a Docker image or it's at least used as a Docker image. In this case, I'm actually technically using a action path, but I can also use an image path if I wanted to use my own Docker images to run certain steps. So the platforms here is a really great feature. This is what I'm able to use with BuildKit to build concurrently on all three platforms, and that's a BuildKit feature. This is something inside a BuildKit when you use the Docker buildx command on your local machine. And now if you're just installing Docker desktop, I think nowadays it's just enabled by default with everything. And I care about these three platforms. They're the most used platforms for my Linux software, so I'm going to build it in all three of those. The builder, remember the builder I'm going to be using is this one I built up here, this BuildX. Although now, let's see. Steps, BuildX, outputs, name. I'm just realizing that maybe I need the ID up here. I might need that. I'm not sure, actually. Not actually sure if that's true. Steps, BuildX, outputs, name. Anyway. So that may be true. I could be wrong on that. This is how I enable the cache. Again, this is subject to problems. I may not have it set up correctly. So I'm going to have to check that documentation and come back to this. Then the push, this is after it's built. Does it push? And if it pushes, is there a conditional? So this is an interesting thing that I also learned from Crazy Max is I can now make a conditional in here that says don't push during a pull request. So this is that workflow I was looking for. I want to build the image, which is essentially my way of testing. I want to build that image on each commit to a pull request for the main branch. Other branches I don't care about, but once there's a pull request that's open, I want it to test this each time there's a commit on that branch. But I don't want it to push images to my registry until I've accepted it to my main branch. And that's what this is doing. It's basically saying, don't do this for pull requests. And then tags, I'm getting the tags and these labels both out of this metadata step. So this right here is outputting tags and labels, and I'm going to use that as the input here. If I didn't want to use this step because maybe I just don't need all that complexity, I can just hard code tags and labels right here, which is what I used to do before I learned about the metadata from Kevin. Then I would just hard code them here, not knowing any better. And I might have even created sort of a bash step where I would maybe do some bash date time functions and other things that I no longer need to do with this, right? Now, as a bonus, I also learned about something else recently. I can throw in this last little step that will print out the digest. So just in case I want better documentation in my runs of exactly the digest of that build, I can just spit that out sort of as a result. And that's pulling from the Docker build step, this right here. Notice how those IDs are being used there? All right. So I have this. Now, what you'll notice, though, is I've created this in a way that only these two lines are unique to this entire job. Everything else is just super generic, as long as my repos always have these standard 2 secrets, which I still need to add. And the only other thing that's not generic are these things up here, these little paths. So eventually, someday, when we get composite actions finished, my hope is that my job will be very standard, and maybe I'll do like all this stuff as a setup step, and then maybe I'll have some custom testing steps based on the apps. So I'll do all this stuff. I'll set up Docker Hub, GHCR, Docker layers, caching, all that stuff. Then I'll build the image, but do nothing with it. Technically, you're going to do a load. If you know about BuildX, you have to load it into Docker. So it'll load it into Docker for use. So the image will be sitting in my job as a Docker image, ready for use. Then I'll do all my testing, and then the last step will be if it succeeded and it's on my main branch, go ahead and push it to the registry. So I think in the future I'll have one step that does all the pre-work, all my actual testing steps, and then my push step. But for now, because we don't have this feature in GitHub Actions, I have to kind of hard code them all in this job. All right. Or I could, make my own custom, I suppose, my own custom GitHub action and like use it that way. But we're not going to go down that rabbit hole. We're just going to stick with this. I think this is ready to test. Now, there are ways to test this locally. But to save us time, I am not going to do that. I'm just going to simply commit this and hope for the best. And I'm hoping that my format. One of the things is if you're using Visual Studio Code, because this is a YAML and there's a specification for it, it should pop up and notify you of you'll see little squigglies and other things if you're not using this correctly. So I highly recommend using using Visual Studio Code for writing your actions. There's even a plugin, which you won't see yet, but what it's going to do is it's going to see from our repo the runs as well as any secrets that I've stored and other things. It's all blank because we haven't set a single one up yet. But before we push this, I'm going to need to go over and get a token. So I'm not going to do this live because then you would see my tokens. But if you didn't know this, Docker Hub has security tokens now. So if I go under security in my Docker Hub account, I can create access tokens, which are essentially passwords for robots. I know my password, but my password is 2FA enabled. Robots typically can't do 2FA, so I have to create hard-coded, non-expiring, long codes that are randomly generated, and I tend to create one per repo because I'm not limited on how many I can create as far as I know. So I just create one per repo, and that makes it the most flexible. If I ever have an issue with something, I can just delete this thing right away, and it'll only affect that repo. So I tend to name them per repo. And then over in my repo, we're going to cancel this because we're not going to do this in the web UI. Over in my settings, this is where I add secrets. If I scroll down under secrets, you'll see that I've already created a token there. I need to add one more for my username. So I'm going to create a new repository secret, Docker Hub username. It's technically not a secret, but that's how I pass environment variables and things. I just need to get my username from Docker Hub over to here, and then that is what will work right here. See these things? I need these keys in there. Otherwise, those environment variables won't pass and they'll get an error. All right. Now that I have those two secrets, I think we're ready to push. And Alexandra says, if I, this is a little bit ago, but saying that, yeah, you can use concurrent builds with ARM. You can do it today, technically, if you're using a private repo, because you can have your own runners, which I was wanting to set up, but then GitHub really discouraged me from doing that for open source. So I'm not going to use private runners on my own hardware to prevent abuse. All right. So I'm going to go in here, and I've got one file that I've added. I'm just going to commit it. I'm going to do all this in the web UI, in this Visual Studio Code GUI. And I'm just saying here that this is GitHub Actions init for web. And so, yes, take all my changes. And then I'm going to push this branch to origin, which is my repo. And then I'm going to create a pull request. And I'm not going to do this here because it's going to open up in a different browser. So what we're going to do is over here in the website, you'll see that it says, hey, you just made a new branch. Okay, so let's make a pull request. Because none of this stuff is going to run until none of the actions are going to kick off. Because remember my rules at the top, my triggers, it's not going to run until I say, I'm using the main branch by default. And so I'm going to compare, say, I'm initializing this. And once I create the pull request, that's when you'll see things start to happen. And then after a couple of seconds, you'll see it realize that a particular workflow needs to be run. And this is automatically built in. So I didn't have to go find a plugin or add a third-party CI into my GitHub. It just automatically happens here. Now my details page. So it's going to be running through all of that for a minute. And if I did it correctly, it will build and it'll work. No promises. All right, so I have a failure. You'll see that by the red X. And we'll see what I did wrong down at the bottom here. Ah, yes. Okay, so I'm in a mono repo. This is a great example. In a mono repo, my build that I copy and pasted in, this little build stuff, I need to tell it where my Docker file's at, right? And that's technically known as context. I don't want this to copy everything in the repo into Docker for building. I only want it to copy web, which is that subdirectory of my source code. So I need to tell it that so that it knows where my Docker file at, where my source code's at, and to only put that subdirectory stuff into the context of Docker when building the image. This is something you have to do locally, right? I would have to go into that directory, CD into it before I did a Docker build. And so I'm going to do that same thing. I'm going to commit the code there. Add context. Commit, yes. And then I'm going to push it. And then back over my web UI, if I go back to actions, you'll see that it's already kicking off. It's recognized that that's what yellow means, is it's recognized there's a new workflow that needs to kick off, and it's going to be queued, and now it's starting. And we'll see if I did that correctly. Mike asks, is the free access sufficient to try using this as a personal GitHub account? Yes. So technically, I think they count it as runs. So the free accounts, every account gets a certain number of runs, as well as storage and other things. And I'm not sure it's minutes. I think it's runs, but I could be wrong. But yes, the free accounts get access to a certain amount of GitHub Actions. Basically, it's a consumption-based thing. So if you run out, you can always buy more, evidently. I've never run out. I'm on the paid personal plan. But all right, so we have a failure again. And this is the typical workflow, right? I build and push. I could test this locally. There is a third-party GitHub Actions local runner, but I'm just doing this in sort of the workflow that would help you see. Okay, so build X call failed with error, executor failed running, sh go build dispatcher, exit code 2. All right, so one of the things here is what I might be running into is, remember that I asked BuildX to build on 3 different platforms. So it's building for AMD, ARMv7, and ARM64. So if you see here, you see that each one of these lines, like this one says ARMv7, ARM64, and AMD64. So it looks like it's erroring for me on the ARM builder. if I'm having BuildX problems, I can just do BuildX commands locally and troubleshoot those without making more commits. By the way, this is also why I love doing all this in a PR branch, because at the end, squash and merge, right? Squash and merge, so that you don't see all my mistakes, all my failed runs. Essentially, they will be down below, but the top one will be green, and you won't see 20 different commits of me going, oops, oops, oops. So I'm a huge squash and merge fan. What we need to do here is I'm just going to get right into the terminal here and get inside that web directory, and I'm going to test that Docker build. So I'm going to do a Docker BuildX build platform Linux ARM 64. And I just want to do that right there. I just want to build it and see if it finishes. Because I might just have a Go issue with building on other platforms, because this image, another problem was this image has never been tested on multi-platform. Go tends to be pretty solid. It just works, but we might have a problem. All right, so yeah, I have the same error. On ARM. So what an interesting thing I can do is I can try AMD 64 and just see if it builds on regular Linux, on a regular Intel. All right, so it worked fine on AMD, right, on regular Intel build. So let's try, I'm just curious, ARM v7. Let's see if v7 works. It might just be a Go issue that with the build statement, and it also is probably a really old version of Go, because this thing is 3+ years old. I'm also going to look up. I picked a horrible example by a repo that has problems with multi-platform builds. Now, one of the negatives of using QEMU, which is why I wanted to use native builders, is that QEMU can be quite slower at building because it's emulating the processor architecture. So you'll notice that your build commands, whether it's local or on GitHub, they will be much slower. Does Docker Community Edition support BuildX option? Yes. BuildX is a standard feature of Docker Desktop. All right, so interestingly, it builds on v7 and on AMD 64, but not ARM 64. And also, oh, look at that. That's what it is. All right, so I think part of this is maybe that I'm using a really old version of Go, and it's probably not savvy for, yeah, see how I'm using this old version? So what I'm going to do is we're just going to see. We're going to see if this works. I'm just going to use Golang Alpine. And I'm just going to do that. We don't need Edge. All right. So this is like the simplest Go file, Go builder file, right? So I'm just going to use that, and hopefully whatever the issue was will have been worked out. You're going to find this true. I find this true with Java, .NET, like .NET, the new .NET, that if you go back more than a year or two, things start to get really wonky with multi-platform builds. They weren't well supported back then. So let's just see if that works, if that fixes it. Cross my fingers. Yeah, Golang 116. Yeah. Thanks, Conrad. I agree. I mean, part of this whole modernization for me anyway is to hopefully update dependencies, update images. I'm finding images that I've had from 4 years ago that the style that we build them differently now. So if you start going through all of my repos of examples for the last dozen repos in my GitHub, you'll notice all that stuff. All right, we've got it built. All right, everybody thumbs up. Everybody thumbs up the video because we got it built. All right, so and I'm going to just build all three locally just to make sure, but I'm pretty confident this will work. I mean, it's a 30-line. We have a 67-line Go file, so I was pretty sure it wasn't going to be something in Go itself. But yeah, the old versions. So I'm just going to be doing this, by the way, not for production. You want to pin everything, pin your versions, pin your dependencies, pin. But when I'm teaching, one of the things that one of my goals is unless I'm specifically teaching about pinning, is to not force things onto, especially minor versions, maybe major versions, just to make sure things don't break. But what we call this evergreen, this is a term in the training industry, is to keep things current and as working as long as possible for the students so that you don't have to come back every 3 or 4 months and fix things every time something breaks. That's my hope here. All right, I'm pretty confident this is going to work. So we're going to close that. We're going to close that. We're going to go back to we're going to commit that change. So technically, if I was doing this right, I would make a separate PR for the Docker file change, but whatever, we're going to do it here. So let's do that. Yes. Commit. Push. And now what we will see, hopefully, is a build that works. Thank you, Anton, so much for the super sticker. I really appreciate it. I thank you so much. It means a lot. 39 RUB. What is RUB? Rubies? Yeah, thanks, Crazy. Yeah, I might have to look into that Go file later. I did not write it. Elton did. I'll blame him. Now, unfortunately, in my open source work here for these simple examples of things, I don't necessarily test the apps. That's something I got to get better at, is verifying that the app works as intended. But I'm not going to do it. All right. Look at that. Green, baby. We got a green build. So so because it's just one job, it's just going to show up here. It's not going to show pretty graphics or anything. I wish it would break out each of the steps, but you can see those here because each one of them produces the log. So you can look at the logs of each step here. Now you notice that this means it skipped those steps, right? Because we're just in a PR, which is good. I wanted it to skip those steps. I don't want it to push. And one of the ways I can avoid accidentally pushing here is that I'm not letting it even log in. So if I messed up the build and push later, and it would maybe accidentally push when I don't want it to, but it would fail because it doesn't have the logins yet. So now what we're going to do is we're going to accept this pull request. Another wonderful thing, of course, of it all being built in is that I automatically get this here. I don't have to add in a third-party CI as an integration to GitHub. So now I'm going to squash and merge so that you don't see all my ridiculousness. And of course, it will do all that. And I don't really need all that, but there we go. Now, when that happens, it will kick off this again. Oops, under actions, you'll see another one that gets queued. And then what I should do is if I go back over here to my repositories and to the web, you'll see this tag. It says last push 2 days ago. It's kind of small. Last push 2 days ago. What I hope to see is in a minute when this finishes that I will now see 3 different architectures for this image. And then those of you running my courses, like this one in particular is used in Kubernetes Mastery, and that you'll be able to see it in, you'll be able to use it on an Apple M1, you'll be able to use it on a Raspberry Pi, and it'll just work. All right, it built and it's done. We got greens. If I refresh, look at that. All right. Oh, there's always going to be vulnerabilities in my code. I mean, you know, we go over here. Oh, see, now it says no vulnerabilities. Probably because we've updated the images, right? We were using really old Golang and Alpine images. Now we're using the most current. And there we go. You now have 3 different images. You can pull it on all 3 platforms. Now, the last thing I'm going to do, bonus round. Again, warnings on some of the things here, like the caching maybe isn't completely legit. Definitely look at the documentation. Go back in the video. You'll see me talking about that early on. But the other thing I want to do is I want to now add linting. And there's something I love that the problem with linters is there's a ton of them. I don't always know the right one to use or which ones are outdated or which ones are current. So we need a linter of linters. And so GitHub is providing the linter of linters. That is super linter. So if we just search GitHub super linter. And this is a repo of collecting all the major popular linters, sometimes multiple linters for different things. And if you scroll down, you will see this gigantic list that they have. It's almost like the awesome lists, right? So this is the awesome linters list, but they combine it into one action, and it dynamically looks at your repo. And if it sees anything that looks like it belongs to that particular linter, it will automatically lint it. And you can control all of these through some of their configuration. You can, by default, it turns them all on, but they won't run unless they see things that they need to scan. And like for one that I tend to turn off is the copy paste detection. This basically will complain if I've got too many files with the same stuff in them, which is valid in an enterprise environment where you want to make sure you're not copying and pasting code between files and you want to keep it dry. So I will turn this one off. And so you can do all that here. You can turn all these off. You can actually scroll down and you can see the environment variables for, if you just keep going, the environment variables after the configuration section for how to configure the linter, the super linter rather. You can scroll down and all these validate. So you can turn off linters that you maybe don't want. For example, in my case, I didn't write the Go code, so maybe I don't want to throw an error for it because I'm not going to fix someone else's code. I just am using it as an example, right? So I will maybe turn that off. You can also change the configuration of each linter by adding linting rules. So we're going to do all that right now. What I'm going to do is under here, I'm going to add a new workflow because I want this to run in parallel and I want this to run on everything, on every commit everywhere. I don't want this to just run on my PR branches or my major branches. I want it to run on every commit in this particular one. So I want it to be a separate workflow. I could make it as a step in the existing workflow, but I don't want linting to hold up my building. In my case, if my stuff builds, I'm good. Like linting will come, I can work with linting issues later. Those will be a separate failure and a separate pipeline, a separate job rather. There's no pipelines in GitHub Actions. So in a separate job, I'm going to do this, right? So I'm going to have a separate file just called, I'm going to call it linter. And if you look at the example, this is exactly what they do. And I'm going to copy and paste this in. This is code straight from GitHub's super linter example. And they have it on branches main, but I'm going to say I want it in this one on all branches. All right. Technically, I think I could do it like this. I think I could do that. Oop. Yeah, no errors. All right. So it's basically the name of the one job. I'm going to call that lint. And then it's going to check out. And one of these things is it has to check out all the code to look at the differences so that it knows it's not going to relint code that hasn't changed. So it's only going to lint things. Oh, I'm on the wrong screen. So sorry. Thanks for all the text. All right. So backing up, I create a file. It's another workflow called linter. And then as I go, I'm just going to copy this example. I am going to have it on push and pull for every branch, every commit. Basically, if you put code in my repo, it's going to get linted and you're going to see complaints. So down here, I'm checking out code and then I'm linting it. And with their example, they show you that you have to check out going back in time so that it knows what is changed, so that it basically does a diff. So it's only going to lint things that are new. It's not going to lint old code. And I'm going to do it. The default branch is main. I'm turning this one off. This is how you can turn things on and off. Again, all that's in the README of superlinter. It's going to use my GitHub token automatically. And I am going to do a couple of things here. I already know certain rules that I don't like. So I'm going to go in this GitHub directory and I'm going to create a new folder called linters. And this is how the superlinter works. So under linters, if I add the custom files that every linter in the world has a custom override file, if you just start adding those here based on that linter, they will automatically get copied over into the superlinter and used for your workflow. For me, because I do a lot of examples, I have, let's see, this one. So Docker files are technically linted by the superlinter twice. One of them is this one. It's just called the Docker file lint RC. I think that's the linter made by Replicated. And here, I'm just going to do rules. It's technically, I guess it's YAML, even though it's not. Now, I am not specializing in, I'm reusing my tags, right? Because it is just demos. I'm reusing tags, so I'm going to tell it to not warn me if I'm reusing tags and I haven't given specific labels other than latest, because it tends to throw a error for that. The other one is the hadolint. So hadolint.yaml is the other Docker file linter, and they have different rules, so it's, I guess, okay to run both. What's that? See this, what? Oh, seat us. Okay. All right. And then this right here is the ignored. Basically, I don't pin stuff. I know these examples, I'm bad. I don't pin stuff. So there's that. All right. And then I think I'm good to go. So I have my overrides. I have my linter. Let's commit the code. Oh, actually, I need a new branch. So what I need to do is create a new branch and call it lint init. All right. Let's see. Right. So here, lint init. Right, exactly. Do as I say, not as I do. You can't be an example of everything all at the same time. That's the problem with examples, is it's focusing on the example of a thing, but not everything else in the repo is an example of that thing, right? All right, and then we're going to push, yes, push it. And then we're going to do another PR, and then we're going to be done. Okay. Now, over in my repo, it's linting. And it will do, and so what you can see now is I actually have two workflows. I probably need to make a better name for that instead of the CI workflow. That probably needs to be build and push image. And then the lint workflow is its own little separate thing here. And this list will dynamically get updated. So you don't have to do anything about it. It just automatically comes and goes as your workflows change. And then once this is done, hopefully it's green. If not, then I've got work to do on my README, and because it'll mark down lint, it'll do all sorts of linting, right? It's a super linter. So that is that. From here, basically adding tests would be the next thing. I would actually add some tests to test my images before I push them to make sure the app runs as expected. And then I would add badges. So if you look up each one of these linters, like the super linter and the GitHub Actions in general, you can add a badge for each of your workflows. And so you can have a badge at the top of your README that when you click it or when you look at it, we refresh the page, it will be green or red, like you've seen badges before that do that, right? So you can do that per workflow. And this linter may take a while. Yeah, so the super linter, if you don't use they have a minimal one that I probably should have used, a thin linter, but if you don't, it's huge. It's like a gig. So it takes a while to pull and run because it's pulling a gig image. All right. Oh, is it green? It's green. So far it's green. So no issues with my markdown, no issues with my code. That's amazing. That never happens on the first try. So now I have two actions. You'll see they're both workflows are here. They're all green. And people can PR my workflows and all that stuff. The other thing, by the way, that you want to do is go look up, this is the last pro tip, and then I got to run. Under GitHub, you'll want to add there's a way to use Dependabot to automatically PR for any new versions of your actions in your workflows. Because you now made a bunch of dependencies, right? Each one of those actions have their own versions, and who's going to keep up on all that, right? Well, one of the ways you can do that is you just look up Dependabot GitHub Actions. You just Google that, and there will be a little file you throw in here. It's very short. It looks like this. And what it'll do is under here, new file, dot, oh wait, there's no dot, dependabot.yaml, and in that file, in the root of GitHub, if I just put this in, it basically will scan weekly and then give me PRs for each one of the actions in each workflow that needs updated. The only negative is you can't do it bulk. So if you're not careful and you have lots of workflows and lots of actions, you could end up with dozens of PRs all from Dependabot very quickly. So it may be one of those things where you end up turning it off and maybe you run it manually, or maybe you have it run monthly so you can do it all at once, or maybe you let it give you all the PRs, but then you make a separate PR of yourself that does all of the action updates at once. It'll do it for every major, minor, and patch version with Symver. So it can be quite verbose. The nice thing is it's just easy to click PR, accept, click PR, accept, and away you go. So hopefully in a little bit of an hour and a half, that was a good walkthrough of how to do the minimal but best, I think, workflow for making your GitHub repos automated again inside of GitHub Actions. I want to thank my patrons, everyone who supports this show. You go to patreon.com/Bret Fisher. You can see that. You can go over that over there, or you can click down below. And thank you all for supporting my work and this live show. I will be back here again, YouTube Live, next week. If you have ideas for the topics, throw them in the comments. I'll check them out before next week. Ciao, everyone.